Okay, so we are going to be applying system of linear equations. So to determine the best method for solving the system of equations and applying systems of equations. So you have learned 5 methods for solving systems of linear equations. I'm going to show you a table that summarizes the methods and the types of systems in which each method works best. Okay, so here's that table. We have graphing. So that is best when you are going to estimate solutions, since graphing usually does not give an exact solution. So when it calls for an estimation, graphing works pretty good for that. Then we learn substitution. So if one of the variables is in either equation has a coefficient of 1 or -1, its substitution is the best way to go. Okay? So that's where you would just have like x plus 3y equals 5, something like that. So you have a coefficient or a term that has a coefficient of 1. Okay? Then we use elimination by addition. If one of the variables has opposite coefficients in the two equations, so if one's positive, one's negative, and it's the same term, then using addition works best. Now, we also did elimination using subtraction. So if one of the variables has the same coefficient in the two equations, so they're both positive, they're both negative, then you would use subtraction. Then lastly, we talked about elimination using multiplication. So if none of the coefficients are 1 or -1, and neither of the variables can be eliminated by simply adding or subtracting the equations, then you have to use elimination using multiplication. All right. So substitution and elimination are algebraic methods for solving for solving systems of equations. An algebraic method is best for an exact solution. Graphing, with or without technology, is a good way to estimate a solution. A system of equations can be solved using each method. To determine the best approach, analyze the coefficients of each term in each equation. So here's an example. It says, at a baseball game, Henry bought 3 hot dogs and a bag of chips for $14. Scott bought 2 hot dogs and a bag of chips for $10. Each of the boys paid the same price for their hot dogs and the same price for their chips. The following system of equations can be used to represent the situation. Determine the best method to solve the system of equations, then solve the system. Okay, so we can write 2 equations. So that would be 3x plus y equals 14 and 2x plus y equals 10. Since neither the coefficients of x nor the coefficients of y are additive inverses, you cannot use elimination using addition. Since the coefficient of y in both equations is 1, you can use elimination using subtraction. So you could also use the substitution method or elimination using multiplication. Okay? So there's a couple that you could use. The following solution uses elimination by subtraction to solve this system. So 3x plus y equals 14. We could just simply subtract 2x plus y equals 10, and we would end up with x equals 4. We can then substitute 4 in for x and solve, and y equals 2. So this means that the hot dogs cost $4 and the bag of chips cost $2. So again, it's just figuring out which method you think works the best and then solving. All right, so determine the best method to solve each system of equations, then solve the system. So what method do we think would work the best? So figure that out, then solve it, and come back and check and see how you did. All right, let's see how you did. So you would have to use elimination by multiplication. So the way that I did it, and of course you could have done it a little bit differently, I multiplied the first equation by 5, the second equation by 3, and that gave me my y's of a positive 15y and a negative 15y. I then ended up, after I added them, I ended up with 34x minus 68, divided both sides by 34, x equals 2. I plugged 2 back in and solved for y, and I got y equals 2, so my solution set is 2, 2. All right. So here's 2 more examples for you to try. It says, then solve the system of equations. So try both of these and see what you come up with here as well. So let's see how you did. So the first one, I would do elimination by addition. So when you added them, you would end up with 5x equals 20. Divide both sides by 5. You get x equals 4. Substitute 4 in, and you're going to get y equals 1. So you'd have a solution set of 1. On number 3, if you rearrange it, and you have y plus 3x equals 24, and negative y plus 5x equals 8, or the other way, simply could do elimination by addition. You would end up with 8x equals 32, divide both sides by 8, x equals 4, plug 4 back into original and solve, and y equals 12. So you'd have a solution set of 4, 12. All right. So this one says, a library contains 2,000 books. There are 3 times as many nonfiction books as fiction books. Write and solve a system of equations to determine the number of nonfiction and fiction books. Okay, so we would set up a system of equations. We could say, N for nonfiction plus F for fiction equals 2,000 books. And then we know that there are 3 times as many nonfiction books as fiction books. So we could say nonfiction would equal 3F. Okay? Since there's 3 times as many nonfiction books, you would have to multiply fiction times 3 to equal each other. Okay? Now we could change this. We could subtract 3F from both sides and get N minus 3F equals 0. And so then we could bring that over here, and we could say N minus 3F equals 0. So we take a look at this and we decide which way would be the best way to do this. Now we are looking for the, so we're trying to determine both the fiction and the nonfiction books. So the best that I would do is do subtraction, because that would subtract out the nonfiction books. And that would give me 4F equals 2,000. Divide both sides by 4, and F equals 500. So I know there are 500 fiction books. Then I would go back up to just taking 2,000. I could go N plus 500 equals 2,000. Subtract 500. And my N equals 1,500. Ooh, that's 15,000, a little too much. So 1,500 non-fiction. Okay? And you'll see that's 3 times as many. All right. So now, applying system of linear equations. When applying a systems of linear equations to problems, it is important to analyze each solution in the context of the situation. So, a t-shirt printing company sells t-shirts for $15 each. The company has a fixed cost for the machine used to print the t-shirts and the additional cost per t-shirt. Use the table to estimate the number of t-shirts the company must sell in order for the income to equal expenses. So we know that the initial income and the initial expenses and the rates of change of each quantity with each t-shirt sold. So we need to write an equation to represent the income and the expenses. Then solve to find how many t-shirts need to be sold for both values to be equal. So we could let X equal the number of t-shirts sold and let Y equal the total amount. So for income, we know that we're selling them for $15 a t-shirt. So there's no initial cost, so it'd just be Y equals 15X. And then the expenses, we know that the initial cost is $3,000 and it costs $5 per t-shirt. So there's our system of equations that we can use. So we could take a look at that and we could use substitution very easily in this problem. So everywhere there's a Y, we would substitute a 15X. Okay? So it'd be 15X equals 3,000 plus 5X. We would subtract 5X from both sides. We get 10X equals 3,000. Divide both sides by 10, and we end up with X equals 300. So this means that 300 t-shirts are sold. The income and expenses of the t-shirt company are equal. Okay? All right. So now refer to what we just talked about, that last example, and if the cost of the t-shirt company changes to the given values and the selling price remains the same, determine the number of t-shirts the company must sell in order for the income to equal expenses. So the only difference is the printing machine is going to be $5,000. So we're still going to have Y equals 15X because we're still selling them for the same amount. And then we're going to have Y equals the initial cost plus $5 a t-shirt because it still costs the same to make them. Okay? So we would have 5,000 plus 5X. I believe that's what it was. Yes. Okay. So then we could use substitution again, and we would have 15X equals 5,000 plus 5X. Subtract 5X from both sides, and we end up with 10X equals 5,000. Divide both sides by 10, and X equals 500. So we need to sell 500 t-shirts. Okay? So the key to this is just looking at the problem, deciding which of the five, and you're really not going to use graphing, I don't believe, so which of the four would be the best way to solve. Okay? Once you determine that, then go ahead and solve and get the solution. All right, if you got any questions, let me know. Have a great day.